Here I have a problem from the UNC 2000 math contest, and it asks us to find the area of a rhombus whose side lengths are 10 and whose diagonals differ by 4. So let's jump into the solution. In the top left-hand area of this board over here, I'm going to sketch out what that might look like. We'll have a rhombus of side length 10, and I'll go ahead and sketch that in here, that all of these sides are of length 10. This long diagonal will color in orange, and the short diagonal will color in yellow. And we'll say that the yellow diagonal has a length of x, and we'll say that the orange diagonal has a length of x plus 4. And now we can go about finding our area. First, we know that because this is a rhombus, it has right angles at the intersections of the diagonals. So because of these right angles, we know that this rhombus is split up into 4 right triangles, one in each quarter of the rhombus. But that means that x over 2 squared plus x plus 4 over 2 squared is equal to 10 squared by the Pythagorean theorem. And that's because the side of the rhombus is the hypotenuse in this case, because it's the opposite of the right angle in all of these right triangles. So now let's go ahead and expand this out. We'll have x squared over 4 plus x plus 4 squared over 4 equals 100. We get x squared plus, and then I'll go ahead and expand out this top term as well. We'll have x squared plus 8x plus 16 is equal to 400. Okay, so I simplified this down a little bit as well. I combined the x squareds on the left-hand side. Now we need to subtract 400 from both sides. So we'll have 2x squared plus 8x minus 384 is equal to 0. Now, dividing 2 out of the whole thing, we'll get x squared plus 4x minus 192, which is all equal to 0. But now this equation factors very nicely as x plus 16 times x minus 12 is equal to 0. But because we're talking about area here, we're only worried about the positive solution, which is x equals 12. X equals negative 16 doesn't really make a whole lot of sense in a area geometry setting. So now we can plug this x equals 12 back into our values up here for the diagonals, and we'll see that this short diagonal is 12 because it's just x, and this orange diagonal is 16. But now we can split the rhombus into 2 different halves, each containing a triangle. And we can use the triangle area formula to find the area of each triangle. So the area of one triangle is equal to 1/2 base times the height, but the base is the entirety of this length of the orange long diagonal, and the height is half of this yellow short diagonal 12, so that's 1/2 times 16 times 6. But that's going to be 48. But now notice we have 2 of these triangles. We have this right-hand side triangle that I've kind of been pointing to, and we also have this left-hand side triangle. So our total area is equal to 48 times 2, which is 96. And that's enough for now.